Find dy by dx if y is equal to x upon x square plus 1. Now here we apply the quotient rule to obtain dy by dx. So this is of the form numerator upon denominator. So the quotient rule is denominator into derivative of numerator minus numerator into derivative of denominator upon denominator square. So applying the quotient rule, we get, now differentiating with respect to x, we have dy by dx is equal to, we begin with the denominator, that is x square plus 1 into derivative of numerator, that is x, minus the numerator, that is x, into derivative of x square plus 1, the whole thing divided by x square plus 1 the whole square. Now simplifying further, we have x square plus 1 into, now derivative of x is 1, minus x times, now here we apply the addition rule for differentiation. So derivative of x square is 2x and derivative of 1 is a constant, so its derivative is 0. So we close the bracket, divided by x square plus 1 the whole square. Now let us simplify this. Now 1 into x square plus 1 gives x square plus 1 and x into 2x. So we have negative 2x square divided by x square plus 1 the whole square. Now if we simplify this further, we get dy by dx as, now this 1 remains as it is. Now x square minus 2x square is minus x square. So in the numerator we have 1 minus x square upon x square plus 1 the whole square. So this is the value for dy by dx. Find dy by dx if y is equal to x square upon x square minus 1. Now here we could apply the quotient rule for differentiation. Now you know that the quotient rule for differentiation is denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. So applying the quotient rule on this function, and we have differentiating with respect to x, we get dy by dx is equal to, now denominator is x square minus 1, so we have x square minus 1 into derivative of numerator, that is x square, minus the numerator, that is x square, into derivative of denominator, that is x square minus 1, the whole thing divided by denominator square, that is x square minus 1 the whole square. Now simplifying this further, we have x square minus 1, so x square minus 1 into derivative of x square, derivative of x square is 2x, minus this x square remains as it is, into, now here we apply the subtraction rule, so derivative of x square is 2x and derivative of 1 is a constant, so its derivative will be 0. So we just close the bracket here, divided by x square minus 1 the whole square. Now in the numerator 2x could be taken out as the common factor. So if we take 2x as the common factor, so within brackets we have x square minus 1 and minus x square. the whole thing divided by x square minus 1 the whole square. So x square cancels with minus x square. So we have 2x into negative 1. So that is negative 2x divided by x square minus 1 the whole square. So this is the value for dy by dx. Find dy by dx if y is equal to x plus 2 the whole square into sin x. Now here we could apply the product rule to obtain the derivative. So differentiating with respect to x, we get dy by dx is equal to, so we have the first term, that is x plus 2 the whole square, into derivative of the second term, that is sin x, plus sin x into derivative of x plus 2 the whole square. Proceeding further, now this term remains as it is, x plus 2 the whole square into derivative of sin x is cos x plus sin x into, now before taking the derivative, let us expand this using the formula a plus b the whole square. So that would make things easier, or else we need to apply the chain rule. But it's easier to expand. So x plus 2 the whole square could be expanded as x square plus 4x plus 4. And now we take the derivative of each of these terms. So we have x plus 2 the whole square into cos x plus sin x into, now derivative of x square is 2x plus 4 times derivative of x. Derivative of x is 1, so it is 4 times 1, which is 4, and derivative of constant 4 is 0. So we just close the bracket here. Now rearranging the terms, this term we keep it as it is, so x plus 2 the whole square into cos x plus, now taking 2 as the common factor from this term, so we have 2 times x plus 2 into sin x. So this is the value for dy by dx. Find dy by dx if y is equal to x square plus 4 times cot x. Now here we apply the product rule or the multiplication rule and obtain dy by dx. So differentiating with respect to x, we get dy by dx is equal to, it's the first term into derivative of second term plus the second term into derivative of the first term. So that is what the product rule says. So we have x square plus 4 into derivative of cot x plus cot x into derivative of x square plus 4. Proceeding further, we have x square plus 4. Now derivative of cot x is negative cos x square x plus, here we have cot x into, now in this part we apply the addition rule since we have two terms in addition. So derivative of x square is 2x and derivative of 4 is 0. 4 is a constant. So we just close the bracket. Now rearranging the terms, we put this negative sign in front. So we have minus of x square plus 4 into cosec square x plus, now this term could be written as 2x into cot x. So this is the value for dy by dx.